So today we're doing rational sign charts and inequalities. We did polynomial sign charts and inequalities last week, so this is very, very similar. Obviously, we're dealing with rationals instead of polynomials. So before we talk about what a rational function is, we talked last week about what makes a number a rational or an irrational number. You could explain either one to me, I don't care. But can anybody explain to me what a rational number is or what an irrational number is? One or the other? Okay, 1/2 is an example of what? Rational or irrational? Rational. Okay, can you give me an example of an irrational number?
Would it be like pi?
Pi or I? Well, yeah, I would work, I think. Yeah, absolutely, because I is the square root of -1. So if I have pi or the square root of a number, those are irrational because I cannot represent them as a fraction. 1/2 and 0.5 are both rational numbers because 0.5 I can represent as a ratio, hence rational number, and represent it as a fraction. So when we talk about rational functions, these for sure are not new to you. They are for sure part of Algebra 2. Even in a crazy school year. So this is an example of a rational function. It's not just that the function is a fraction, it's that there's variables in the denominator. So if I had, this is my numerator, but the denominator was just 5, that's not, even though that's a ratio and it's a fraction, it wouldn't be a rational function because that 5 could just come out in the front as like 1/5. But when you have variables in the denominator, that's what makes it into a rational function, okay? That's as opposed to a polynomial. All right, so let's look at the inequalities. This is almost word for word what it was for polynomials, except for it says rational function instead of polynomial function. So if you have a rational function, you can have a rational inequality, general form, greater than or equal to, not equal to, less than or equal to 0, and all of those. So the inequality, if I have f of x is greater than 0, what does f of x always represent? Y. Okay, so where my y's are greater than 0, that's true when f of x or y is positive. Remember, anytime you talk about the value of the function, you are talking about the y value. X is not the value of the function, y is the value of the function. So then when it's less than 0, that's when f of x is negative. Okay, hopefully that is glaringly obvious to you. And then let's look at this function. So they have graphed this function for us because we have not graphed rationals together yet. That is something you would have done in Algebra 2. We haven't done it, but it's graphed for us. But one of the things that is missing from here is the asymptotes. Okay, so we're going to sketch those in. This is an asymptote. This is an asymptote. And then I also have a horizontal one right here. Okay. My horizontal asymptotes help me with end behavior. Okay. The vertical asymptotes help me with middle behavior, and that's more what we're really focusing on right now. So although we drew in all 3 of them, the horizontal one really isn't going to affect what we do so much as far as these sign charts are concerned. We're going to use it. It's going to be important to us, and it actually makes sense right here too, but it's not really necessary for our sign charts. Okay, so now it says, name all the intervals for which f of x is greater than 0. So when is the function positive? All right, well, the function is positive here. And because of this horizontal asymptote, I know that my end behavior means that this function is right around here, so it should stay positive the whole time. It's also positive here and here. So we're going to write our intervals just like we did before. That's when your y values are positive, but our intervals are always of x. So I start way out here at -infinity on the x-axis. It's positive until we get to 3. Do I include 3? I'm sorry, negative 3. Do I include -3? What's the value of the function at -3? What's happening at -3? An asymptote, because there is no value, right? The function does not have a value at -3, so I can't include it. It's not positive, negative, or 0. It just doesn't even exist. Then I start back over being positive at -1, and I'm positive until I get to 2. Do I include -1? No, because that's when it's 0. Do I include 2? No, because there's no value there at all, right? Then I start back over again at 4 and go to infinity. I know I never include my infinities, but I'm not including 4 either because that's when it's 0. Okay? If that said greater than or equal to 0, then I would, but that's not what it says. All right, so then for when it's less than 0, that's negative. It's right here and right here. So it starts being negative, not at negative infinity, even though that's the y value. My x value is -3, and my function stays negative until we get to -1. I don't include this one because it's an asymptote. I don't include that one because it's a 0. Then I start back over at 2 and go to 4. Don't include this one because it's an asymptote. Don't include that one because it's a 0. Okay. What questions do you have? All right. So let's look at this. Says notice that a rational function switches signs at both its zeros. Because remember when we were doing polynomials, we knew if it was going to go from negative to positive, I had to cross through the x-axis, and so it had to cross at a 0. But our signs change here at both the zeros and the vertical asymptotes. But we're going to rewrite one of these words here because it says that a rational function, it's actually the rational function. You don't have to switch signs at an asymptote because let's say instead of going like this one went this way, then it would be positive here and positive on the other side. That's a possibility. So we don't have to switch signs, but we need to say, notice that a rational function can switch signs at both. Okay, so it doesn't necessarily have to, because it can even bounce and then it doesn't necessarily change. Okay. But basically what that's getting at is we have to take into account, we only looked at our zeros on polynomials because it's really all we had. We have to focus on our zeros and our vertical asymptotes here. So our steps to create a sign chart. We set it equal to 0. We can totally do that. Did that with polynomials. We find the zeros of both the numerator and denominator by factoring. We can do that. Plot these points on a number line. And then it says asymptotes always get an open circle. So when we get to inequalities and we have to decide on our zeros, are they opened or closed depending on the inequality, asymptotes are always open no matter what because you're never going to have a value there, hence that vertical asymptote. Right? Then we choose test points just like we did before and we shade. So really the only difference is that this is a rational instead of a polynomial. All right, so let's create one for number 1. So our first step was to set it equal to 0. Right? And then I'm supposed to solve, and I don't need a factor because this one's a super simple one. I have to get my zeros from the numerator and the denominator, and they give me two different things. My numerator 0 is actually the zeros of the function. So I only have one 0, it's -5. My denominator zeros, if I substitute in, if I make the denominator 0, and I have x plus 5 over 0, there's no value there, right? What's happening on my graph at that point? When I don't have a value at all. What is that thing? Asymptote. So if I substitute in -2 and I get x plus 5 over 0, I don't get to divide by 0 and get a real or get an actual value for my function. See the little poster over there, n over o, undefined? It's not defined at that point. That is your vertical asymptotes. So my vertical asymptote, and these are lines. So it is an equation of a line. It is x equals -2. It's not a statement about x being -2. That is the equation of a line. This is a set of zeros. Okay, we good on that? Both things go on my number line. So I put in this -5 and a -2. My -5 is a 0, so since this isn't an inequality, I don't even have to think about it. It's closed. -2 is my asymptote, so it is open. It is always open. Then we're going to do the same thing we did the other day with the picking a number. So between -infinity and -5, I'll pick -6. When I substitute that in the numerator, that gives me a negative number. I substitute it in the denominator, gives me a negative number. Negative divided by negative is positive. Between -5 and -2, I'll pick -3. That gives me a positive in the numerator, gives me a negative in the denominator. That's negative overall. Then I'll pick 0, because I can pick 0. That would give me clearly positive, positive. That's positive overall. So this is what my sign chart looks like. Positive, negative, positive. Okay. What questions do you have? Anything? Easy enough? We just got to make sure we handle our rationals correctly. All right, so let's look at number 2. On number 2, I'm going to set this equal to 0. This one I do have to factor, so my numerator is still x. My denominator, when I factor, I'll have x and x. This tells me the signs are different. What are my two numbers? -6 and 1. Good. 2 and 3 are pretty tempting because 2 times 3 is 6 and 2 plus 3 is 5, but it doesn't work that way. And this is equal to 0. So from this, the zeros of the function are the zeros of the numerator. All that is 0. My vertical asymptotes come from the zeros of the denominator. So this one would give me x equals -1 and x equals 6. Remember, those are equations of lines. That's why they are written that way. All three of these things go on my number line. So I'm going to have a -1, a 0, and a 6. My -1, is that opened or closed? Open. What about 0? Closed. And 6? Open. Very good. So I've got 3 things I have to put my sign in here because I'm using this. So I'll start with -2. So that would give me negative over negative times negative. So those 3 negatives give me negative. Then I'll use -1/2. That would give me negative, positive, negative. That's positive overall. Then I can use 1. So that will give me positive, positive, negative. Then I can use 7, which will be positive, positive, positive. So this alternates, but remember that does not happen every single time. Plus, I want my sign chart actually written out, and I'm going to show you why. So let's see, let's shade this in. And then even though we have not sketched rationals together, and you may not really even remember doing it last year, we can sketch, get a general idea of this graph. Because remember, this number line represents my x-axis. My y-axis, I could draw it in right here if I wanted to, but I'm not even, it's not necessary. Let's think about, why did I put open circles here? What's actually here on my graph? Asymptotes. Okay, so let's sketch in our asymptotes. Okay. Then, here's what I know. From -infinity to -1, my function is negative. So, and I know at an asymptote, it's going to be hugging the asymptote going down or going up. Clearly, it's not going to be going up. It's going to have to be going down right here, right? And it stays negative the whole time. So I have a horizontal asymptote somewhere. It could be at 0. It could be, but it couldn't be a positive. It'd have to be at 0 or a negative number. Maybe it's at -2, and I haven't figured that out yet. But either way, in general, my graph over here should look like this. It's kind of the only thing that could happen. I'm just unsure of really, how far up this would go, but it gives me the general idea. Then, between -1 and 0, my function is positive. From 0 to 6, my function is negative. Again, I'm hitting asymptotes, so I know it has to hug it either up here or down here. Clearly, this is positive. I come down here, and then this is going to be negative. So in general, it looks like this. Then I have another asymptote, and it's positive the whole time. So this is going to have to hug the asymptote up here. And again, my horizontal asymptote, this tells me, because I'm not going to have 2 there, it does have to be at 0. Otherwise, this would have to go down farther. So looks something like that. That's the general shape and everything of your function. So sign charts are hugely helpful, especially when they get a little weird, because we're going to look at some that are a little weird, but they're not impossible because the sign chart super important and helps you out a lot. Okay, we good? All right. So let's look at number 3. I'm going to set this equal to 0. Then I can factor x plus 3 times x minus 3 over x plus 4, and that equals 0. So it's all factored. The zeros of the function come from the zeros of the numerator, so that's going to be plus or minus 3. The vertical asymptotes come from the zeros of the denominator, that's x equals -4. Okay. So I'm going to have on here a -4, -3, and 3. Bless you. All right, so you go ahead and finish this up. Get your open and closed circles on there and find your signs, all that good kind of stuff. What questions do we have? Are we good? Yes. No questions? All right. Then let's look at the rational inequality. So same type of steps, but we're going to have to actually solve the inequality. I'm not going to draw the graph on this one. So for steps, we're going to do the same thing and then write the solution. So we have to set it equal to 0 and factor. So it, or equal, to 0. So it is equal to 0. So I'm going to factor. Numerator is going to give me x and x. The signs are the same and they're both negative. This will be -1 and -4 over x times x plus 2. And that's less than or equal to 0. So my zeros come from the numerator. I have 1 and 4. My vertical asymptotes come from the denominator. X equals 0, x equals -2. So I have 4 things to put on here. I got a -2, a 0, a 1, and a 4. Now, for my zeros, I have to look at this. This says less than or equal to, which means my zeros are closed circles. So 1 and 4 are closed circles. My asymptotes are open, always, no matter what that inequality says. Okay. So then, this is what I'm substituting it into. I'll start with -3. So that'll be negative, 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 negative over negative, negative. That's positive overall. Then I could do -1. That'll be negative, 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 positive. That's negative overall. 1/2 will give me negative, negative, positive, positive. That's positive overall. 2 would give me positive, negative, positive, positive. And then 5 would give me positive, 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 positive overall. So then I'm going to shade. And then on this one, I'm not done after shading because I'm trying to solve an inequality. And this says I want it to be less than or equal to 0. So that's when I want it to be negative, right? So it's negative starting at -2 and going to 0. Do I include -2? No, because that's an asymptote. That's why I have the open circle, right? And I don't include 0. I start back over at 1 and go to 4. Do I include 1? Yes, because it's a closed circle because that's a 0, and I include 4. So if you get your circles done correctly on here, you can use the open and close to help you with the brackets, and that's your answer. What questions do you have? We're good? All right. Let's look at number 7. So this isn't set equal to 0. We need to do that first. So I would have x minus 7 over 2x minus 2 minus 1 is greater than 0. So is this going to become x minus 8 over 2x minus 2? Did I just get to subtract that from the numerator? I'm subtracting fractions. What do I have to have? Common denominator. So this 1 has to become 2x minus 2 over 2x minus 2, right? So my common denominator is 2x minus 2. My first numerator is x minus 7. Then I'm going to subtract 2x minus 2. Yep. Then I'm going to go up here. So in the numerator, that's going to give me, so x minus 2x is negative x. Negative 7 minus a negative 2 is negative 5 over 2x minus 2. It's going to help me tremendously if I factor out my GCF. So I'm going to factor out a negative. That's going to leave me with x plus 5 over 2 times x minus 2, and that's greater than 0. Now that I have it factored, I'm going to get my zeros from the numerator. That's going to be negative 5. And my vertical asymptote will be x equals 2. And this is the part I'm going to use to help me solve all of this. So I have negative 5 and I have 2. Is negative, I'm sorry. Yes, it would. Thank you very much. Yes. Oh, God, I hope I didn't do that last period. I didn't even see your hand. Thank you. Yes, if I factor that out, it makes it x minus 1. So x equals 1, and this should be a 1. Thank you very much. I have a really bad feeling that's what I did last period too, but they never correct me, ever. So yes, that should be a 1. Thank you. Though my negative 5, is it opened or closed? Open. It's a 0, but I look at this, right? So it is open. And then 1 is a vertical asymptote, so it's always open. So then when I substitute this in, I'm going to use negative 6. Now when I put it in here, this gives me a negative, but I have to multiply it by a negative, so the numerator is actually positive. And then this negative down here stays negative. When I put in 0, this gives me 5, but then this negative makes it negative, and then it's negative down there. That's positive overall. When I put in 2, this gets positive, but then I multiply it by a negative, and 2 in here makes the whole thing positive, so this is negative. Then a shade, negative, positive, negative. And I want this to be greater than 0, so it's positive. This is what I'm looking at. So it's positive from negative 5 to 1. I do not include either one of them because they're open, but the negative 5 is because it was greater than 0, and then the 1 is because it's an asymptote, and that's what it looks like. What questions do you have? All right. Last one. Set it equal to 0. So I'm going to get 9 over x minus 4 minus 8 over x minus 3 less than or equal to 0. I need a common denominator. So I got to multiply the first one by x minus 3 over x minus 3, the second one by x minus 4 over x minus 4. So my new denominator is going to be x minus 4 times x minus 3. I do not want to multiply that together because I want it factored. My numerator is going to be 9 times x minus 3 minus 8 times x minus 4. I'm going to continue this up here. My denominator is still x minus 4 times x minus 3. This gives me 9x minus 27 minus 8x plus 32. That's less than or equal to 0. My denominator is still x minus 4 times x minus 3. 9x minus 8x is x. Negative 27, positive 32 is 5. Now it's all simplified and factored. My zeros come from the 0 of the numerator. My vertical asymptotes come from the zeros in the denominator, so I get x equals 4 and x equals 3. And then this is what I'm using. I'm going to box it so I don't get it mixed up with everything else. Yes? How did I get x plus 5? Oh, because I simplified this right here. 9x minus 8x is x. Negative 27 and positive 32 gives me 5. Okay. Then I'm going to put a negative 5, 3, and 4. Is negative 5 opened or closed? Closed, right? Because it's less than or equal to. And then these are asymptotes, so they're both open. Okay. Y'all finish that sign chart up and put your solution there. And I will hand out your worksheet. Okay, so if I substitute in negative 6, that will give me negative over negative negative. That's negative overall. I can use 0. That'll give me positive negative negative. That's positive. I can put in 3.5. That'll be positive negative positive. And then 4 would give me, I'm sorry, if I put in 5, that would give me positive, positive, positive. That is positive overall. So when I shade, I get negative, positive, negative, positive. And then when I write my answer, I want it to be less than or equal to 0. So those are my negatives here and here. So from negative infinity to negative 5. And I include negative 5 because it's less than or equal to, and that's a 0, plus I have a closed circle there. Then I start back over at 3 and go to 4. I do not include either one of them because they're asymptotes and they're open circles, and this is my answer. And there you go.